All right, so what we're going to do is work on our lesson on completing the square. That's going to help us learn how to solve some quadratic equations. So what we need to do is select all expressions that are perfect squares. Now here we have x plus 5 times 5 plus x. So first, if I use the commutative property of addition, I can rewrite this as x plus 5 times x plus 5. And then I notice my base is x plus 5, and I'm multiplying that twice. So I can write that as x plus 5 squared. So this is a perfect square. So here I have x plus 5 times x minus 5. I can't write that as a perfect square. Here, x minus 3 squared is written as a perfect square, so yes. Here I want to say yes for number 4, x minus 3 squared, but if I do my order of operations, 3 squared is 9, so this is really x minus 9, and nothing is squared here, so nope. And then for number 5, I need to factor. So what I'm going to do here is list factors of 16, and I want them to sum to 8. So I do this in my head. I just think, well, I have 1 and 16, and 2 and 8, and 4 and 4. Then when I add those, I have 17, 10, and 8. This works. So then this factors into x plus 4 times x plus 4, which is equal to x plus 4 squared. And then my last one, I'm looking for factors of 20 that add together to be 10. Well, 1 and 20 are 21. 2 and 10 are 12. 5 and 4 is 9, so this is not factorable. So this one was, and that one wasn't. So now what we're going to do is work on taking quadratic expressions and putting them into factored form. So here I'm looking for factors of 9 that sum to 6. I think, well, 9 can be 1 and 9, and when I add those, 1 plus 9 is 10, so no. And then 3 and 3, 3 plus 3 is 6. So this can be written as x plus 3 times x plus 3, which does equal x plus 3 squared. Same idea here. I'm looking for factors of positive 25 that add together to be negative 10. Now, I know I'm looking for perfect squares, so 5 and 5 are going to be it, but 5 plus 5 is 10, not negative 10. So I actually have to rethink that and think negative 5 times negative 5 is positive 25. But when I add negative 5 and negative 5, I get negative 10. So my perfect square here, I have x minus 5 times x minus 5, which is equal to x minus 5 squared. And then when I multiply x minus 7 squared, that's going to equal x minus 7 times x minus 7. And then when I distribute that out, that's x squared. And then I have minus 7x minus another 7x. And then plus negative 7 times negative 7 is plus 49. So to combine my like terms there, negative 7 plus negative 7, or negative 7x plus negative 7x is going to give me negative 14x. So over here, I have x squared minus 14x, and then plus 49. So now what we're going to do is work through a process called completing the square. Now, if I have over here x squared minus 20x, and I want to make it a perfect square. So I'm trying to figure out, well, what would I add to it to make it a perfect square? I'm going to start by drawing in an area model. So here I have x squared. Now, what I want you to notice is on a perfect square, these x terms are the same. So negative 20x is split into two equal parts. So essentially what we're doing is taking negative 20x and dividing it by 2, and negative 20 divided by 2 would give us negative 10x. So into each of those parts, I'm going to put negative 10x and negative 10x. So we have x and x, and then minus 10 and minus 10. And then over here, I can see I have x minus 10 times x minus 10. So x minus 10 is going to be squared. We filled in that part. But now I have to figure out, well, what I add. What do I add? So negative 10 times negative 10 is positive 100. All right. So for number 5, we have x squared plus 16x. Well, if I'm trying to think of my two terms, we have x squared and 16x. Well, dividing that by 2, I'm going to have 8x and 8x. So on the outside, I'm going to have x and x, and it's going to be x plus 8 and x plus 8. So that's going to be x plus 8 squared. And then 8 times 8 is going to give me 64. And then for my last one, we'll draw another picture. We have x squared plus 7x. So we have x squared here. 7x divided by 2 is going to be 3.5x. So we have 3.5x and 3.5x. So I'm going to have x and plus 3.5 and x and plus 3.5. And then when I multiply 3.5 times 3.5, you get 12.25. So I have x plus 3.5 squared, and then this is 12.25. Now, if I did this with b, so if we have x squared, so we're going to have x and x. And then if I take bx and divide that by 2, that's what we're going to have in each part. So b over 2x, b over 2x. So here I'm going to have x plus b over 2 squared. And then to figure out, well, what am I going to add? Well, b times b is b squared. And then 2 times 2 is 4. So I'm going to add b squared over 4. So now we're going to dip our toes into completing the square. So one technique for solving quadratic equations is called completing the square. So here's 2 examples of how Diego and Mai did just that. So first of all, we're going to focus on how just one person completed the square. So sorry, Mai. We're going to look at how Diego did it. So Diego's process, he has x squared plus 10x. He moved the positive 9 to the other side. So if I'm looking at that, he is creating a perfect square. So we have x squared right here, which would break down into x and x. Now, if I have positive 10 to split into 2 equal parts, that's going to be 5x and 5x. So on the outside, it's going to be x plus 5 times x plus 5. And then figuring out, well, what do we add? Well, 5 times 5 is 25. So if you notice, Diego added 25 to both sides. And then that gave him x squared plus 10x plus 25 on the left-hand side of the equation, which we know factors into x plus 5 squared. and then that's equal to 16. And then we break that up and take the square root. So x plus 5 equals 4, and x plus 5 equals negative 4. And then subtracting 5 from both sides. So 4 minus 5 is negative 1. Subtracting 5 from both sides, negative 4 minus negative 5 is negative 9. So what we're going to do is use that method, and I'm going to model number 1 and number 2 and leave 3 for you to do. So the first thing that I have to do is move the positive 8 over to the other side. So we have x squared plus 6x is equal to negative 8. And then a reminder, that's going to be a middle term split into 2 equal parts. So if I take 6x and divide that by 2, that's going to give us 3x on both parts. If I draw my picture here, you can see we're going to have x squared, 3x, and 3x. So this is going to factor into x plus 3 and x plus another 3. And then to figure out, well, what do I add? 3 times 3 is 9. So I'm going to add 9 to both sides. And then in factoring that, you get x plus 3 squared is equal to 1. Now to undo the squaring, we take the square root of both sides. So I just show that, and I get x plus 3. And then when I show the square root of 1, which is going to be 1, I write plus or minus 1. I do that because that forces me to see I have to split this up into 2 equations. So my 2 equations I write are x plus 3 equals positive 1 and x plus 3 equals negative 1. Then subtracting 3 from both sides, I get x is equal to negative 2. Subtracting 3 from both sides, we have x equals negative 4. So that was number 1, and we solved for those 2 answers. Let's work out number 2. So we have x squared plus 12x is equal to 13. Now what I'm going to do, we're going to split that into 2 equal parts. So I'm adding 6. I'm going to do that without the picture, and I know that we're going to have x plus 6 being squared. And then if I remember, I'm going to multiply 6 times 6. So 6 squared is 36. So I'm going to add 36 to both sides. So 13 plus 36 is equal to 49. So now I'm going to take the square root of both sides, and I have x plus 6 equals. Square root of 49 is 7, but had I not done my trick up here, I know it's actually 7 and negative 7. So I always write plus or minus 7 because it reminds me to split it into 2 equations. So x plus 6 is equal to positive 7, and x plus 6 is equal to negative 7. So then subtract 6 from both sides. And I did both equations. In the first equation, 7 minus 6 is 1. So one solution is x equals 1. Over here, negative 7 plus 6, we get x equals negative 13. So we have 1 and negative 13. Those are 2 examples. And I will stop off here. Don't forget to do the assignment on the back.